Hello, my name is Teacher Iman, and welcome to GED Mathematics Live at PALS. In this video, I will be presenting the topic Exponents and Roots. Before I continue, let me share with you the targets. The targets are: evaluate expressions that contain exponent, identify and understand the rules of exponents, apply the rules of exponents in solving problems, simplify expressions that contain square roots and cube roots. What is exponents? Exponents are common shorthand used in mathematics. You have probably seen terms like 4 with a superscript 2 and 3 with a superscript 4. Both of these are written with exponents, and these are read as 4 to the second power and 3 to the fourth power. This is why sometimes you hear people call exponents powers. Let's look at the basic parts of a term with exponents. The whole number is the base, and the small number, the superscript number, is the exponent. In a term like the one shown, the exponent tells how many times to multiply the base by itself. Look at this term, 2 to the 6th power. 2 to the 6th power has an exponent of 6. And again, the exponent tells how many times to multiply the base by itself. Since the exponent is 6, we are going to multiply 2 6 times. 1, 2, 3, 4, 5, 6. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Another is 4 to the second power. The exponent is 2, so we need to multiply 4 2 times. So 4 times 4 is 16. 3 to the fourth power. The exponent is 4, so we need to multiply 3 4 times. So 3 times 3 is 9, times 3 is 27, times 3 is 81. Let's look at some special rules and some terminology that we should be familiar with in regards to exponents. The first one is any number with an exponent of 0 is equal to 1. So it means regardless of how large is the number, if the exponent is 0, the value is equal to 1. Okay? So remember that condition. So 4 to the power of 0 is equals to 1. 2/3 to the power of 0 is equals to 1. 1215, this is larger than the other two example, but the exponent is the same, 0, still the value is equals to 1. Another one is any number to the power of 1 is just that number. So again, any number to the power of 1 is just that number. So 8 to the power of 1 is equals to 8, still the number. 1/2 to the power of 1 is equals 1/2, still the same, still the number. Another one is any number to the power of 2 is said to be squared. Any number to the power of 3 is said to be cubed. So be familiar with this term. So squared and cubed. Like for example, 5 to the second power can also be read as 5 squared. 5 to the third power can also be read as 5 cubed. Another special rule is negative exponents. Okay, here is the rule. Okay, the definition of the rule. So the base has a negative exponent. So what will you do if the base has a negative exponent or the term has a negative exponent? If the term or the base has a negative exponent or a number has a negative exponent, you should make the exponent positive by looking for the reciprocal. Okay, so the reciprocal of a with an exponent of negative n is equals to 1 over a to the nth power. Okay, let's look at the example. 5 to the power of negative 2 is equals to 1 over 5 to the second power, or 5 squared, which is equal to 1 over 5 times 5. The answer is 1 over 25. Let's look at another example. Example number 2, 3 to the power of negative 1. So find the reciprocal. 1 over 3 to the power of 1. Any number with a power of 1 is still the number, so the answer is 1 over 3. Okay, example number 3. 2 to the power of negative 4 is equals to 1 over 2 to the power of 4, or to the fourth power. So the answer is 1 over 16. Let's try some problem. Okay, the direction is evaluate each of the following expressions containing exponents. I want you to pause the video. Give yourself time to answer the questions, number 1 to number 10. Then when you are finished, press play to check your answer. Are you finished? Then let's answer. Evaluate each of the following expressions containing exponents. Evaluate, it means we need to solve. So the first one is 3 to the second power, or 3 squared, is equals to 9. 1 to the fifth power is equals to 1 times 1 times 1 times 1 times 1 is equals to 1. Number 3, 12 to the power of 1. Any number with an exponent of 1 is still the number. So the answer here is 12. 7 to the third power, or 7 cubed, is equals to 7 times 7 times 7 times 7 is equals to 343. 2 squared is 2 times 2 is equals to 4. Any number with a zero exponent is 1. Any number with a negative exponent, we look for the reciprocal and then solve. So 1 over 8 squared is equals to 1 times 8 times 8 is equals to 1 over 64. A number with a negative exponent, again, we look for the reciprocal. So 1 over 6 to the power of 1. Any number with an exponent of 1 is still the number, so the answer is 1 over 6. Okay, 4 to the power of negative 3. So find the reciprocals of 4 to the power of 3, or 4 cubed, is the same as 1 over 4 times 4 times 4, which is equals to 1 over 64. Okay, the last one is 1 with a negative 4 exponent. So we need to make the exponent positive. So we have 1 over 1, 1 to the 4th power is the same as 1, 1 times 1 times 1 times 1, which is equals to 1 over 1 is equals to 1. So still 1. Okay, as you can see, it's easy to evaluate each of the following expressions containing exponents if you are familiar with some special rules and conditions that you need to consider. Let's look at the rules of exponents. Okay, I'll be giving you several rules that we need to take notes that might help us in evaluating and simplifying expressions. Rule number 1, when multiplying two terms with the same base, add the exponents. A to the n power times a to the m power is equals to a to the power of n plus m. Let's look at an example. Example 4. Using the laws of exponents, write a numerical expression that is equivalent to 4 to the power of 4 times 4 to the power of 2, or 4 squared. The instruction says write a numerical expression. So all we need to do is write a numerical expression that is equivalent to 4 to the 4th power times 4 squared. Okay, 4 to the 4th power times 4 squared is equals to 4 to the power of 4 plus 2 is equals to 4 to the 6th power. So this is our expression equivalent to this, to the given. Let's try another example. Okay, the instruction is using the laws of exponents, write a numerical expression that is equivalent to 1/2 cubed times 1/2 to the 6th power. Again, we will gonna be writing a numerical expression that is equivalent to the given. So let's write it again. 1/2 cubed times 1/2 to the 6th power. Okay, since the base fraction is the same, so we can just add the exponent. So we have 1/2, 3 plus 6. So the answer is 1/2 to the 9th power. Rule number 2. Okay, rule number 2. When dividing two terms with the same base, subtract the exponents. And here's the rule, the definition of the rule. On the GED test, you may see division written with the usual division symbol, or you may see it written as a fraction. Both of these are shown in this rule, and both mean the same thing. So a to the power of m divided by a to the power of n is the same as a to the power of m over a to the power of n. They both mean the same thing. Let's try an example. Example 6. Using the laws of exponents, write a numerical expression that is equivalent to 3 to the 5th power over 3 to the 2nd power. The two terms have the same base and are being divided, so apply rule number 2. 3 to the 5th power over 3 to the 2nd power is equals to 3, 5 minus 2. The answer is 3 cubed, or 3 to the power of 3. Another example, example number 7. Using the laws of exponents, write a numerical expression that is equivalent to 4 to the 5th power divided by 4. Write an equivalent numerical expression. 4 divided by 4 is equals to 4, 5 minus 1 is equals to 4 to the 4th power. So this is our numerical expression. Okay, let's proceed to rule number 3. Rule number 3, to take a term with an exponent to a power, multiply the powers. Okay, let's see the definition. So a to the power of n to the power of n. Okay, a to the power of m to the power of n. So in this case, we multiply the exponent. So m times n. A to the power of m times n. Okay, let's look at the example. 3 to the power of 2 to the power of 4. So we multiply 2 times 4. The answer is 8. So the new expression is 3 to the power of 8. 1/3 to the power of 5 to the power of 3. So 5 times 3 is 15. So 1/3 to the power of 15. Let's see example 8. Simplify the expression 4 to the power of 3 times 4 to the power of 2 to the power of 2. Okay? So this time, we will be applying rule number 3. So inside the parentheses, maybe I should make some shortcuts. 4 to the power of 3 is 3 plus 2 is 5. So the exponent 5, then the exponent outside is 2. So the answer is 4 to the power of 10. Okay, 4 to the power of 10. Okay, let's try some actual problem. Okay, the direction, simplify each of the following expression. Okay, this time again, I want you to pause the video and try answering questions number 1 to number 10. When you are finished, play the video again and you will find the answer to the questions. Okay, are you done? Okay, if you are done, here are the answers. Simplify each of the following expression. So number 1, 2 to the power of 8 is equals to 256. Number 2, 1 over 5 to the power of 3 is equals to 1 over 125. Number 3 is equals to 1 over 6 to the power of 3. Number 4, 8 to the power of 16. Number 5, 1. Number 6, we have 3 to the power of 3 to the power of 3 is equals to 3 to the power of 9. Number 7, 1 over 7 to the power of 7. Number 8, 4 to the power of 5 to the power of 3 is equals to 4 to the power of 15. Number 9, 18 to the power of 4. Number 10, 9 to the power of 12 times 9 equals to 9 to the power of 13. If you know the rules of exponent, it is easy to simplify expressions with exponents. Let's proceed to square roots and cube roots. Square roots and cube roots. Square roots and cube roots are two ways of undoing exponents. Okay, let's see. 6 squared is equals to 36. Okay, because 6 times 6 is 36. Now, square root of 36 is equals to 6. Okay, you are looking for the root that when you squared, the answer is 36. Okay, another example, 2 cube. Okay, 2 cube is equals to 8. 2 times 2 is 4 times 2 is 8. Yeah, that's correct. And cube root of 8 is equals to 2. So again, square roots and cube roots are two ways of undoing exponents. Now, numbers for which the square root or the cube root is a whole number are referred to as perfect squares or perfect cubes. It is a good idea to know some of the common perfect squares and perfect cubes. Look at the common perfect squares and perfect cubes on the screen. Okay, square root of 4 is 2, square root of 16 is 4, 36, square root of 36 is 6, square root of 64 is 8, square root of 100 is 10, square root of 144 is 12. Yeah, square root of 9 is 3, square root of 25 is 5, square root of 49 is 7, square root of 81 is 9, square root of 121 is 11. So these are the common perfect squares. These are the common perfect cubes. Cube root of 8 is 2, cube root of 27 is 3, cube root of 64 is 4, cube root of 125 is 5. Expressions involving square roots and cube roots can be simplified by using your knowledge of the perfect squares and cubes. That's why it is very important to have a knowledge and understanding of the basic perfect squares and perfect cubes. Let's see some examples. Example number 9. Simplify square root of 72. Square root of 72 is not a perfect square, but we can simplify it. And to simplify it, what will you do? You need to look for the factor of 72, which one of the factor is a perfect square. So 36 is a perfect square because the factor of 72 it could be 36 times 2 is 72. And the square root of 36 is 6. Then square root of 2 doesn't have a whole number answer. So the simplified answer is, or the simplified form is 6 the square root of 2. Example number 10. Simplify square root of 12. Okay, square root of 12 doesn't have, or square root of 12 is not a perfect square. So let's look for the factors of square root of 12, which one is a perfect square. So 4 times 3 is 12, and square root of 4 is a perfect square. The answer is 2. Then copy the square root of 3. It is also true with cubes. Look at example 11, the cube root of 32. 32 is not a perfect cube root. Okay, so we need to look for a factor that, or we need to look for factors which one is a perfect cube root. So 8 is a perfect cube root. Cube root of 8 is 2. Cube root of 4. Okay, 4 still remain inside because 4 doesn't have an exact whole number root. Now let's proceed to our drill. Again, I want you to pause the video and then try answering questions number 1 to number 10. Simplify each of the following using your knowledge of perfect squares and perfect cubes. When you are finished answering the questions, you can play again to check your answer. Are you done? Let's check. Simplify each of the following using your knowledge of perfect squares and perfect cubes. Square root of 32. 32 doesn't have a perfect square root, but we can find a factor which one is a perfect square root. So square root of 16 times 2. Okay, square root of 16 is 4. Then square root of 2 remains. Okay, so 4 the square root of 2. Square root of 18, the factors are 9 times 2. So 9 is a perfect square. So square root of 9 is 3 square root of 2. 40. 40 is square root of 4 times 10. So the square root of 4 is 2. Then square root of 10. 300. Oh, 300 is square root of 100 times 3. The square root of 100 is 10 square root of 3. Number 5, square root of 24. Square root of 24 could be square root of 4 times 6 is equals to, the square root of 4 is 2 square root of 6. Number 6, oh, it's cube root. So same with what we did with the first 5 number with square roots, we will do the same on this problem. So cube root of 16 doesn't have, but we can factor it out. So cube root of 8 times 2. So we have cube root of 8 is 2, cube root of 2. Then 128 is cube root of 64 times 2. Cube root of 64 is 4 cube root of 2. Number 8, 24 is cube root of 8 times 3. Cube root of 8 is 2 cube root of 3. Number 9. Number 9 is cube root of 125 times 3 is equals to, cube root of 125 is 5 cube root of 3. Number 10, cube root of 800 is cube root of 8 times 100 is equals to 2 cube root of 100. Okay, before we end with our lesson, I want you to remember to review several conditions that involves exponents and also the different exponents rules. And you should be familiar also with common perfect squares and perfect cubes. This will help you in evaluating expressions that involve exponents and roots. If you have any question or if you did not understand some part of the presentation, you can comment below. Or you can contact us on our Facebook, Phuket PALS, or you can call us on 081-417-0978, or you can visit us at www.phuketpals.org.